Alright, so I'm getting ready for experiment 26. I've got some weighed out potassium permanganate solid over here. That's about the amount you should shoot for a 0.01 molar solution, 300 milliliters. Roughly 300 milliliters of deionized water there, and then a stir bar in preparation for stirring it. So I'm going to go ahead and send the crystals in there. As you can see, they turn the solution purple immediately. Watch out with this. Definitely wear gloves because you will stain your hands purple if you don't. I would recommend washing down the sides of this with a wash bottle to make sure you get all of those crystals in there. We are going to standardize the solution, so it's not a huge deal if you miss a few. But yeah, just for good analytical technique, you can always wash down as long as you use not too much water and you kind of undershoot the final volume of the solution a little bit. We're going to use sodium oxalate as a primary standard, and what that means is we know the composition, the molecular formula, and the amount or the mass of sodium oxalate exactly. So we can use the reaction between this and the permanganate to determine the amount of permanganate in whatever volume of that solution that we end up using. So it allows us to determine the concentration from there of permanganate to a great deal of precision. Now here, as we did with the permanganate, I'd recommend that you wash this down out of the weigh boat or off the weigh paper using distilled water. Reason being, you want to make sure to get all of this, or as much as possible, into the actual final solution. I don't think the lab manual says to do this, but rest assured that washing a little bit of water into the beaker won't affect the final results. But don't forget to use sulfuric acid when you're making up the solution of sodium oxalate, because hydronium ions need to be present for the reaction to work. At this point, I've got the oxalate and sulfuric acid solution stirring and heating. Remember to heat this to 60 to 80 degrees C before beginning titration. So now I can take my finished potassium permanganate solution, which you see right here, and add it to the burette. You don't necessarily need to add up to the 0 mark here, but add enough that you can add 20 to 30 milliliters of titrant to the oxalate and acid solution. As this stuff is heating up, I would recommend filling up your burette. Remember to read the top of the meniscus when you're recording the initial volume. The only reason for that is because it's really difficult to see the bottom of the meniscus here, and as long as we're consistent in our readings with the top of the meniscus, we'll get the correct final volume, so no worries there. I'd also recommend lifting up the bottom of your burette a little bit higher than you're used to. This way you can keep the oxalate solution, which we're going to add permanganate to, stirring and heating on the hot plate all while you're titrating it. So be a little bit careful here as you set up the hot plate underneath the burette. You'll want to lift this up a little bit more and slide the hot plate and the beaker underneath it. Temperature is at just about 60 degrees, so we can go ahead and start titrating here. You'll want to avoid air bubbles in the burette, so do as I say, not as I do here. And open a little bit slowly so that we get a nice drip rate going there. As you get close to the end point, you'll want to keep your fingers on the stopcock so that you can stop it at the right moment. And think about which direction you're going to turn the stopcock before you turn it. That's kind of a classic mistake that I see. I see myself do it from time to time. So if you really look at that solution, that's got the nice pale pink color that we're going for. So we're right at the end point of the titration right here. Add a little bit more titrant, you can really see that pink color come in. And if it gets to a deep pink, we know that or almost a purple color, we know we've overshot the titration endpoint.